Am I audible?
Yes, ma'am.
Oh. Okay. Some of you have asked that you are okay with electrical systems, but you need some examples in mechanical systems. So we want to revisit those first, and then we'll move forward. If I'm not audible enough, please let me know in between whenever the audio went below the level. Okay.
Okay, ma'am.
Right. Um, as we discussed in electrical systems, we have R, L, C components. In mechanical systems, we will have M, B, K component, where M is the mass, B is the damp, damping or damper, K is the spring. Where spring doesn't hold any memory, mass and damper holds memories. It has the influence of the past input. So when you want to write a force balance equation or any simple free body diagram for obtaining the transfer function, the first thing you can consider is, first of all, force for writing force balance equations. Is there any other voice disturbing in the background?
Very mildly, ma'am, but not disturbing.
Okay, okay. So there will be a force always that exists in a system. So whenever we are considering the component M, B and K, we will always consider the force that is opposing the input force. This is the applied force or the input force we used to call. So when I want to write the force balance equation, let us consider M. So M will oppose the acceleration of the force that has been applied. Mass will offer an opposing force which is proportional to the acceleration of the body. So mass will create an opposing force which is proportional to the acceleration of the body. So this will be proportional to Fm, that is a force, opposing force acting on the mass, where Fm can be redefined as d squared x by dt squared. So this is the acceleration, where x is the position, where double differentiation of x will give us the acceleration, x double dot. So taking the proportionality as a constant, we will have m into d square x by dt. So this force will be proportional to the Fm, where this will be equal to m into d square x by dt square. Right? So this is in terms of mass. When it comes to damping, it will create a force or opposing force that will be proportional to the velocity of the body. So it can be written as Fm proportional to dx by dt. Taking the proportionality out, we will get damp B into dx by dt. So your F equal to B into dx by dt. This is the final value you will get. So when it comes to the spring constant, so spring will create an opposing force that is proportional to the position of the body or a system. So this will be Fm proportional to x. That's it. So taking the position of m equal to k into f, where f equal to m, so f apply the force will be equal to k. So only the individual idealized system I have referred here. For example, here I will consider something like this, only with force F. For this, I can say this has only B with force acting as F. So your Fm will act in this direction. It's an opposing force, right? So it will act in this opposite direction. Here you will have only the K, where the F will act like this, Fm will act in the opposite direction. Now we want to see how we can write if two or more forces are in parallel or series combination. For example, I am considering two spring constants that are in parallel. It's x is a displacement here and capital F is a force here. It's K1, K2. And again, I am considering 2K that has been connected in series with different displacements value. This is y, and the another spring has been connected to another displacement value x, where the common force that is acting at the node is capital F. So how can we write these two equations? What will be the difference between these two equations? So first of all, here the displacement is same. So same force will be applied to both the springs, right? So first force Fm will be proportional to x. Fm1 will be proportional to x. Fm2, that is corresponding to K2, will also be proportional to x. So this will be K1x plus K2x will be equal to the F. So if I consider x as a constant, K1 plus K2 will be equal to F. So I am considering this as a K equivalent, where I am defining K equivalent is equal to K1 plus K2. So ultimately, when this should be like this. Actually, it is spring. I have written it like a resistor. It's like this, okay? Okay, right. So when two springs are in parallel combination, the effective spring constant will be summation of the two values, K1 plus K2. That you have to keep in mind. So the next thing, you would have guessed how this will be. This will be in parallel combination, K1, K2 by K1 plus K2. We are going to see how we derive that. So here there are two different displacements acting upon. So K1 will be proportional to Y because it is being connected to the dead end. M1 that corresponds to K1 will be proportional to Y, where Y is the displacement, whereas Fm2 opposing force from the spring K2 will be proportional to the difference between the two displacements. That will be wherever it is connected, that comes first, X, and another displacement will come in the next, because K2 has been connected between these two nodes. So the effective force acting in between will be proportional to x minus y. So it's like a work done. So the overall force will be K1 y equal to F, K2 x minus y equal to F. So the overall F I am connecting here. So if I want to find the equivalent resistance, I can replace one with other. Here y it is there, here also y it is there. So I can rewrite this into y equal to F by K1. When I substitute here x minus F by K1 equal to F, this will be K2x minus K2 by K1F equal to F. K2x is equal to F plus K2 by K1F. Taking F as constant, K2x equal to 1 plus K2 by K1. Keeping F by x, I will get K2 by 1 plus K2 by K1. This will give me K2 by K1 plus K2 whole by K1. This will again be K1, K2 by K1 plus K2, f by x. So, where I'm considering f by x as a equivalent spring constant here, because I want to keep all the constants, whatever spring constants there in one side, and keeping the rest of the parameters in the next side. So whenever the two spring constants are connected in series fashion, so the equivalent resistance would be K1, K2 by K1 plus K2. So in a complete diagram which involves both mass, spring and damper systems, if you see this type of either the parallel type behavior or series type behavior, you can straight away substitute this instead of solving one by one line. So this will be easy for you if you keep this in mind. Similarly, we will also try doing it for damper systems. So I'm considering two different damper connections. First one is parallel fashion as we did before. The P2. So for the displacement from this side would be x, displacement from the right side, this node would be y. Similarly, I am going to connect the damper in series in the next step, where I am considering displacement x in the first node, displacement z in the intermediate node, and there is another damper B2 and displacement y in the last node. So this displacement varies with respect to how many nodes are there that's being connected in between it. Okay, so as we saw before, for damping, it's for spring it is just proportional to x, so we just took x as it is. But for damping, it is proportional to dx by dt, that is x dot. So whenever you are taking a proportionality between the force and the element equation, you have to consider in terms of single differentiation value for damping. When it comes to mass, it will be double differentiation, x double dot, y double dot, kind of you have to consider. Okay, for the first circuit, I can write since it has a common node, both dampers has a common nodes here, and it involves two different displacement values. Two different displacement values. We are writing first B1 will have the effect of dy, the second node, minus the first node, dy by dt. dy by dt. No, it is not writing. 1 minute. Dy by dt minus dx by dt will come here. Then the second system for B2, it will be again same node has been connected. So this will also be dy by dt by dx by dt. Right? 1 minute. Oh, sorry. Okay. dt, right? For the next system, it will be, this will be force will be equal to same, this node minus this node, b1 into dz by dt minus dx by dt. And again, that is a different one which has a different separate two nodes considered to be, this is a starting in and this is a ending in, v2 into dy by dt minus dz by dt. That's how it is. So we have seen the basics of this mass spring damper systems, individual elements, and we'll see some problems which takes together. There is a spring named K and it has a mass m1. There is a damper b1 and another mass that has been connected to m2 equal to 0, and there is a spring in between these two also, that is K, and the N force that has been acting upon the whole thing is F of T. And I am considering two displacements. X1 displacement is here and another X displacement I am considering here, which acts upon this M1 and M2 respectively. Right? Consider this as B for simplicity. Okay, right. Now we want to write the differential equation governing this mechanical system, which is shown in this figure. So this is K1 actually. And the damping that acts in M1 is B1 and M2 is B2. Individual masses in individual system, the damping value is B1 and B2 respectively, and that it has been connected with a common B in between M1 and M2 also. So there are three dampers in the system, two springs, two masses, and two displacements. First force mass, it will be m into dx1 square by dt square. Similarly, Fm2 will be m2 into d square x by dt square. Can you tell for force on acting upon K1? Can you unmute and tell? Fk1. Will it comes with the individual displacement or difference between the displacements? The K1 is situated between the end and the displacement x1. Then the force upon K1 will be equal to? Can anyone please answer? Then only I will know whether you understood or not. Anybody?
Next one.
Yeah, thanks. So it will be K1 into x1. Similarly, the force that acts here in FB1, I can write here, FB1 will be straight away, right? It will be B1 into dx1 by dt because this is exclusive for mass m1. It's not being connected between any two displacements. Similarly, FB2 is also straightforward, B2 into dx by dt. Now, we are coming to the connected elements between B and K. So, F of B, I have to write carefully, it will be how it will be B into d x1 minus x by dt. Right? F of K equal to K into, there will not be any d, it will be x1 minus x. Correct? Did I miss anything? So for the overall force equation, since it has only one series connection and the parallelism between, there are no nodes to connect two separate systems. So we are going to write it in terms of a single equation. So the overall equation will look like this, starting from M, or we can start from K as in the diagram. So from K, it will be K1x1 plus M1 d squared x1 by dt squared, and B1 is also there. So I'm writing it here, B1 dx1 by dt plus B into d by dt of x1 minus x plus k x1 minus x plus k2. There is no k2, right? Only b2 is there. Plus b2 dx by dt. Can you check once that did I miss anything? 1, 2, 3, 7. 1, 2, 3, 4, 5, 6. 6 only I have written. I might have missed something. Plus M2 I forgot to write. Where M2 will come after K, it will come. Plus M2 d squared x2 by dt squared. Right? Do you have any deviation from this answer? Anyone? So I'm going to write K1. I'm going to take a Laplace transform of this. So to make it easy to write it in terms of a transfer function, it will be s square x1 of s. Anybody has any doubt? No.
No, ma'am, it's fine.
And then x1, and just I want to remind this again. Whenever you are trying to write it in some of a transfer function, any differential equation, we are assuming initial conditions of 0. Why do we consider this? That we discussed in the previous lecture detail. So assuming 0 initial condition, I will only have x1 of s plus b1 s into plus b1 x into x1 of s. Why am I writing it? Plus b1 is x1 of s plus b f x1 of s minus x of s plus k into x1 minus 6. I'm just reading x1 of s to x1, okay? S squared x of s plus b2s x of s equal to 0. So I'm going to write separate x1 terms and x terms separately. This will give me, if I take x1 of s common, k1 plus m1 is squared plus b1 is plus bs plus k, that's it, right? Plus x of s, if I take, it would give me, there is no x of s until here, minus bs minus k plus m2 square plus b2s. Okay, since it's a longer system, it takes a little more time to solve. I guess it's correct. Right. Now I'm going to write another equation in terms of common terms, m1 square plus b1 plus b into s plus k plus x of s into what is common here? S is common here, right? b2 minus b into s. Okay, we'll write m square term first. m2 s square plus b2 minus b1 s minus k equal to 0. Now I have this. So I'm going to keep x1 again alone here. I'm going to keep everything in the right hand side. It will give me I think I'm missing out something. Did I make any mistake?
F is missing.
Which one I'm missing?
Force F.
Can you point out the term in the first x1 of s or
No, finally that F of t.
okay. The force I'm missing this. It's okay. Let us take, I'm considering force as 0 now for simplicity. So this will give me x of s into m2s square plus b2 minus b1s minus k by k1 plus m1 s square plus b1 plus b of s plus k. Seems little okay. Okay, we made a mistake there. I understood. Yeah, I think we made a mistake here. Instead of writing this, we can write it in terms of two equations that will make it less complex. Yeah, sorry. Let me rewrite this. Just this part. Okay. I'm first considering from x1 point of view, then we will consider two different equations, then the substitution will be easy instead of going left and right. K1 x1 is there, m1 d square is there, b dx1 by dt, b1 is there, and b dx by dt is right, k is right. That's it. So with k1, it's over. So this will be first equation equal to 0. I'm considering because there is no force here. First equation. The second equation would be again from k point of view. I'm starting with m2 d square x2 by dt square. Here I'm starting from here, this point of view, m2, and there is no k here with only displacement dx, but b2 is there. So plus b2 into dx2 by dt, plus there are common terms. So now from looking from that point of view, from this direction, it will be x minus x1. So this will become b into dx minus x1, whereas in the previous equation this is x1 minus x. So this is the way from which direction we are seeing. By dt plus k also will be x minus x1 instead of x1 minus x. So again this will be equal to the force, and later we will assume while making the changes. Right, now we have two equations. Now it will be easy to substitute one with other and cancel few terms. So the first equation, taking Laplace, we get x1 k1 x1 of s. I will just write x1, okay, capital x1. It means the Laplace plus m1 s square x1 plus b1 s x1 plus b s x1 minus x, correct, plus k into x1 minus x equal to 0. Good. Now keeping x1 separate, k1 plus m1s square plus b1s minus or plus bs minus x into, I'm taking a minus common, so inside it will be plus minus already it's common, kx equal to 0. Now I'm keeping x1 here and pushing all other terms to the next side. Bs plus ks divided by k1 plus m1s square plus b1s plus bs. Just trying to copy this term here. That's it. So now I have one equation for solving the first equation. Now I'm going to simplify the second equation also. Consider this as 3. So solving the second equation, we will get, this is little difficult to write. So this will become m2 s square x. There is no x2. Every time I'm making this mistake. Right. Is my screen visible?
Yes, ma'am.
Or it went off? Okay, right. This rewriting the second equation, k plus b2 s into x plus again bs to x minus x1 plus k into x minus x1 equal to capital F. Consider this as a Laplace of the force f of t. Taking x common, m2 a square plus b2s plus bs minus x1 bs. Oh, okay, I missed here. Plus k minus x1, this will be bs, again plus k only, equal to f. So this is similar to the equation we wrote, right? Now I'm going to keep should I substitute here? Yeah, I will rewrite it. X into m2s square plus b2s plus bs plus k equal to, okay, x1 into bs plus k plus f. Okay, so I'm going to substitute 3 in 4. That's why I equated to x1. So instead of this, we are going to substitute 3. This will give me b2s plus bs plus k equal to the entire term x into bs plus kx by k1 m1 is, sorry, k1 plus m1 square plus. So if I made some silly mistake before, right? Instead of writing x, I wrote x2 by practice. So this kind of mistakes will lead to negative answers. So you should be careful whenever you are writing this equation. So this is the whole equation you got after the substitution. Right? So we always want to write output by input to find the Laplace transform. So output here is x, that is the last displacement here, and input here is the force acting on the entire system. So I want to write it in terms of this. So I'm keeping this at one side and I'm equating everything else to the other side. So this will become x is equal to this whole term and this term will come 1 by here. Just simplify this as it is little longer. I'm going to leave it here. I'm leaving here since it is taking too much time. if we write in terms of this, we will get the Laplace transform. Sorry, transfer function. It will be Laplace of output by Laplace of input, and it's already transfer function because we already assumed it for a zero initial condition. So the takeaway from this is understand how to write equations for if two systems are in series and parallel. Right? So this is the practice out of this session. So if you have any doubts so far, please let me know. How to write for this system, any example system if you have in mind, you can ask. We can discuss that. Otherwise, we can solve practice problems also. Week 3 practice problems. I can solve one more problem on this, little different, but okay. It's a little famous problem. Wherever you see the question on this, you might be asked this, where the displacement acting upon this mass is y1, and there is another spring that is a common spring to m2. The displacement acting here is y2. So we want to write the find the transfer function of the system where force is being acting in the mass 1. So whenever you are writing equation for mass 1, you have to equate it to f1 or whatever it is. F it is. Let us consider f. There is no other force, so just consider f. Now just start to write from one mass. Whatever displacement it is given there, that will be in terms of acceleration. m1 into d square y1 by dt square plus b into dy by dt plus k into d just y1, because it is not common with anything else, it will be equal to f of t. Any doubt in this? You can say anything I'm missing here, or everything is okay?
Okay, ma'am.
Okay, you're making one mistake here because I left this. This is also connected to m1, no? So this k2 should also be considered while writing m1. So k2 into y1 minus y2 should also be considered in the first equation. When you are writing the second equation, it should be y2 minus y1 since you are seeing from this direction. Right. For the second equation, it's very simple. m2 d square y2 by dt square plus k2 into y2 minus y1 equal to 0. And it's not 0 because I'm first put it on f of, right? Any doubt? I hope I am right.
No.
Thank you. Then you know the steps, right? The hard thing is writing this equation. We don't know how to start and may stuck at some point. After this, find the Laplace transform between that. Find the right one equation in terms of another equation. Then you will get answer. y1 by f of s. So answer should be y2 of s by f of s. So this is the first equation. Second equation, so Laplace of first equation will give us m1 s square y1 of s plus bs y1 of s plus k into y1 of s plus k2 y1 of s minus k2 y2 of s equal to f of s. That's third equation. Second equation becomes m2 s squared y2 plus k2 y2 minus k2y1 equal to 0. So if I want to write it in terms of y2 for the second equation, I have to write it in terms of y1 in the first equation. So keeping y1 constant, m1s square plus bs plus k plus, okay, another k is there, plus k2 minus k2y2 equal to f. This again will be the same terms, f plus k2y2. So y1 will be equal to f plus k2y2 by the whole term. So the second equation becomes y2 m2s square plus k2 minus k2y1 equal to 0. y1 I am substituting these values, k2 minus k2 into f plus k2y2 by the whole term. So just equate this to k2 into f plus k2y2 the whole term into 1 by ms square plus k2. That's it. So rewrite this equation to take f out of it and write it in terms of y2 by f. That is the final answer. So I want also to teach you something about MATLAB, how you can write this transfer functions in MATLAB, and how you can work around those problems that I want to help you with. So we'll present my screen for my laptop. Okay. Now, how can you write a transfer function in MATLAB? There are many ways to write a transfer function. So I'll just save it first. One minute. Network is weak here. So if we want to write a transfer function like tf1 equal to, let's take s plus 1 by s plus 2. Simple. We'll start off with simple transfer function. How you can write here is numerator equal to, so whatever numerator you have, that you can write as it is. Coefficient of the numerator, denominator equal to, in a matrix symbol, coefficient of the denominator. So g1 I am considering the transfer function, name of the transfer function is, you can just give it into a tf, that is a keyword here, tf of numerator comma denominator, whatever. You can straight away write the matrix there also, right? That's it. So if I run this, oh, okay. This okay. This is the transfer function form. You can give it to MATLAB. First, defining a transfer function. The second method is and then we call this as the vector method form. So for this, you need a numerator coefficient and denominator coefficient. It is easy to write in terms of transfer function like separate form, I can say, like this kind of transfer function. For example, it will be a square 1 a square plus 2s plus 2 by s cube plus 3 plus some 5s plus 0 or 9 I'm taking. So if you want to write this kind of transfer function that is not factorized, it is this method is easy. You can write is 2 2, just write the coefficient as it is 3 1 3 5 and 9. That's it. See, it will come as it is. So then another method to write the same transfer function is that using s. So if I want to keep s as it is, if we're considering it's of higher orders, for example 10th order or several orders, 7th order something. So that time I will use another form which is called factored form. So in this method, for example, I want to write a transfer function like this. Yes, transfer function 2 equal to s plus 2 into s plus 4 I have by s plus 7 into s plus 8 into s plus 9. Let's take. So I can write this in terms of first I'm writing similar to that numerator as it is, whatever coefficient it is there, but here you have to write it in terms of root value is if there is s plus 2, you have to write it in terms of s is equal to minus 2 form. So you should be careful here, otherwise this will go wrong. And the denominator I can write as minus 7. Just keep this in mind, these are different kinds of writing the transfer function. Whatever way you are comfortable, you can go with it. There is no particular form you have to do this or that. So ZPK, the keyword here is ZPK. So we'll have numerator comma denominator. That's it. So this will give me the actual transfer function. I think I have to include the control system toolbox for this. this needs a gain also. So if there is no gain, I will just consider k as it is. K equal to 1 here. So it will give it in this form. If you want it in a factorized form, if you want to find a Laplace transform or find the partial fractions and all, so this step would be helpful. This is another step to do the same thing. Right. If you want to write it in terms of, I don't want to write it in terms of coefficient, I want to write it in terms of S terms itself. So while doing a fast calculation, this will be helpful. So I want to keep as it is. So the first step, I can use the same transfer function like this here. So I'm going to do one keyword. S is equal to transfer function of S. So whatever S you are considering, consider that as a part of a transfer function. That's what this line tells the MATLAB. So you can just straight away write TF3 equal to the same thing you can write here. But just that when writing this, you have to be careful with this multiplication and all this notations. That's it. You'll get the transfer function out of this. And I guess this ZFPK also works here. If I write it in terms of ZPK of S, and if I write the same thing here, TF4, factorized form of those things. That's it. So you can see the difference between these two. If I define S is equal to TF of S, TF of S, this gives in the whole format S square plus 2S plus 2, S cube by plus 5S plus 12. So if I write it in terms of ZPK of S, then it is giving in terms of a factorized version of the denominator. It continuous time, it's in terms of pole zero modeling. So in whatever way you want to get the transfer function out of the system, you can use either numerator denominator transfer function of or ZPK of. Otherwise transfer function of S you can define and you can straight away give this. If you don't define this, and if you run this program, okay, it has a memory, right? See, so the unrecognized functions are variable. Yes, this error will come. So now you will be familiar with this error. So whenever this error throws, you have to define what the S is here. Otherwise, you have to write it in terms of a coefficient. Any doubts in this?
No.
Okay, I hope that's clear. Okay, we can solve some problems. I think that's it with the MATLAB. Can you solve this problem? And tell the answers in the comment section. Let us practice this electric circuit now. So consider I1 here, I2 here. Can you solve this problem? I want to find the transfer function in terms of V0 by V or V1. And I will give you the values also. R1 equal to 2 ohm, C1, C2 equal to 1 farad. 1 farad. R1, R2 is also 2 ohm. So solve this in your notebook or something and let me know the answers in the comment section.
Ma'am, show the circuit, please.
Oh, I'm sorry. I don't know, there is some issue here. It is showing it is being stopped because you stop presenting something. It's visible here, right? Now it's visible. If we want to mute, I'm sorry. I want in terms of V naught, right? If we solve like this, I will get it in terms of I. So if I want to get it in terms of V naught, I want to use this method cannot be used. Although it is right, this won't you to the answer you want. So we have to do voltage division rule. So here, when we write equation in terms of this regular equation, we won't get any answer in terms of V naught. So we won't get any terms in terms of V naught. Otherwise, you have to consider this 1 by C1 of S into IS into voltage across the capacitor. You have to write it in terms of that. So it will be little twisted. So we can directly solve this using a shortcut called the voltage division rule, where if I connected two resistors in series with respect to a voltage, the voltage across this R1 would be V1, voltage across R2 would be V2. So each voltages can be found using this formula. If you want to find the same voltage, it will be V1, here also R1. If you want to find V2, it will be R2 by common denominator R1 plus R2. In current division rule, it will be little different. If you want to find I1, it will be R2 by R1 plus R2. where I2 it will be R1 by R1 plus R2, because in series circuit voltage is different, in series circuit current is same. Similar thing, we will do this voltage division rule and try to find the answer for this. So I am going to combine this into a single network where R1 and C1 are considered clear single element together for better visualization, and this R2 and C2 are considered to be a separate element. So, right? So everything is connected in series with the voltage V1. So I want to find the voltage across this C2. That is V0. Okay. Right. So consider this as a single element. Consider the other block as another single element which is connected in series. So if we want to find the voltage across the first element, V1, that is Vi or V1, the input voltage would be R1 plus 1 by C1S. I'm straightly writing in terms of Laplace equation, divided by R1 plus 1 by C1S plus this whole term R2 1 by C2S by R2 plus 1 by C2S. Right? This is V1, where we want voltage across V2, right? I guess I'm correct. This will be R1 C1S, R2 C2S by R2 plus 1 by C2. That's right. And the first one gives, as it is in series, it will be, okay, where R1 is 2, R2 is also 2, C1 is 1, C2 is also 1. Substituting this 2 plus 1 by S by 2 plus 1 by S in plus 2 by S by 2 plus 1 by S. Okay. So this will be V1 . Okay, I'm sorry, I want V not here, right? So there will be V here. So if I want to write it in, this is for VA. So if I want to write it in terms of V naught, the same if I consider, it will be R2 by R2. It's in parallel combination. So it will be R2 by C2S by R2 plus 1 by C2S divided by the whole, this term as it is, plus this term R1 plus 1 by C1 is right. Okay. So this is what the answer is. Let's just substitute the value for R2 equal to 2 by S by 2 plus 1 by S divided by 2 plus 1 by S plus 2 by S divided by 2 plus 1 by S. Since C1, C2 are 0. So this will give me 2 by S by 2 plus 1 by S as it is. I'm not going to solve that. 2S plus 1 plus, oh, like that. So I can take this as a common denominator plus 2 by s by 2 plus 1 by s, right? So this and this will go cancel. 2 by s divided by 2s plus 1 the whole square plus 2 by s. So this is the answer. Or you can write vi here. That's the transfer function. So if you don't get this, please ask me in which step you're stuck. If you don't have any doubts, we can proceed to solving practice problems. I guess we have enough practice in the mechanical system now. So practice quiz 3, the first question you won't have any problem, I guess. You will be able to solve it. I will just give the first equation, you can cross check it with that. So we have a system that has one B that looks like this, and parallelly there is a K1, let us, right? It is connected to K2 to an end where the displacement is x0. And we have a simplified another system that has a B and there is a M and another B. It is called B2. Maybe this is B1. This also has a displacement of x0 from mass and it's connected to a end. So find the transfer function of each of two mechanical systems where x represents the input. Where is x1? Oh, there above. Okay. x1 represents the input and x represents the output displacement. Okay. So for the first equation, k is connected to only the x0. K2 is connected to x0, whereas K1 is connected between these two displacements. So K1 is x1 minus x0 plus B into x1 minus x0. Sorry, d by dt of plus K2 into x0 equal to 0. This is the first equation for system 1. Just check whether you are getting the same. For the second system, B is connected between these two, then it will be B1 will be in between d by dt of x1 minus x0 and m will be d squared x by dt squared x0 only plus b2 is connected to only x0, d by dt of x0 will be equal to 0. So this is second equation for system 2. That's it. You can take Laplace transform and write it in terms of x0 by x1 and find the correct options. If you get this right, you will get that right also. Consider 0 initial conditions. Second question is, if you want me to solve further, I can help you with that. If no, we can go forward with next systems. Linear system initially at rest, meaning 0 initial condition, is subjected to a input signal that is r of t equal to 1 minus e power minus t, where t greater than or equal to 0. So for all t greater than or equal to 0, this will be 1 minus e power minus t. For t t less than 0, they didn't give any condition. Okay, the condition is the system, the input is causal. It will start only at 0. The response of the system for t greater than or is equal to is given by, oh, this is like we solved during the Monday problem, I guess. Okay, they have given an input response and output response in time domain. You are asked to find the transfer function. We know the relation, right? Transfer function is equal to Laplace of output by Laplace of input at 0 initial conditions. That's it. First find the Laplace of both equations separately and then write it in terms of C of S by R of S. That's it. You'll get the equation. So for R of S, if I find the Laplace of R of S, it would be 1 minus 1 by S plus 1. C of S would be 1 minus 1 by S plus 2. So this will become 1 minus 1 by S plus 2 by 1 minus 1 by S plus 1. S plus 2 plus 1 by S plus 2. S plus 1 minus 1 by S plus 1. So give me S plus 3 by S plus 2 by S plus 1. Again, how can I write this? I have to find a way to write it properly so that I can find the inverse Laplace transform easily. How can I write? Oh, I missed a term here. This will be 1 by S, no? Laplace of 1 will be 1 by S. Then this won't be this complex. That's it. 1 by S minus 1 by S plus 2 by 1 by S minus 1 by S plus 1. Just can straight away find it, I guess. This will become S plus 2 minus 1, S plus 1, S into S plus 2. This will also be the same. Give me so this will be the answer. Minimum possible. Shortest form of the answer. This is the transfer function of the system. Right. The third question and fourth question are common data. If the system has a closed loop transfer function given as, they have given a closed loop transfer function C by R 10 by S plus 2 into S plus 4. Output response they have asked. Okay. So you need to find the Laplace inverse. First do partial fractions and then do Laplace inverse to get the output response, that is in terms of C of t. For that you need to know what is R of t, right? Sorry, small r of t. So it was given in the question, that is unit step. So R of S would be 1 by S, that's it. Or R of t equal to 1 into U of t. These two partial fractions and take inverse Laplace transform, put R of S equal to 1 by S. So the answer become 10 by s plus 2 into s plus 4 into 1 by s. That's it. I take partial fractions a by s plus b by s plus 2 plus c by s plus 4 equal to 10. Find a, b, c values. Then you will get something like a e power 1 by s will be 1. Will be a plus b e power minus 2t plus c e power minus 4t. Something will come out like this. That's your output response. So in the fourth question, which is a continued question, in the system mentioned above with closed loop poles located in the left half of the S-plane, which of the following statement is true? So in the question, the poles are in left up, they said s equal to minus 2 and s equal to minus 4. So that will be like this, sigma j omega minus 2 and minus 4. Two poles will be here. So the system is naturally stable, closed loop system is naturally stable. There are four options. The output response contains exponential terms with positive integers indicating an unstable system. That will not be correct. Steady state output as t tends to infinity is non-zero and transit output dominates. Okay, the system is absolutely stable and the transient terms approaches 0 as t tends to infinity. Poles at s equal to minus 2 and s equal to minus 4 indicate unstable system. Okay, we know the system is naturally stable, right? The first option suggests output response, that is C of t, will contain an exponential term with positive indices. They say it will be a unstable system. That's what they are telling. So we don't find any positive indices here. This is constant. This is a negative exponential, negative exponential. So this statement will not be true. A will be a wrong statement. B statement would be steady state output at t tends to infinity is non-zero. Steady state output. Okay. So when a system reaches a steady state, either this way or this way, whatever way, based on the initial condition. So it reaches a steady state value, it will be a non-zero. That's what they are telling us. T tends to infinity. Okay, it might be. And transient output dominates. They're saying that the transient will dominate this more than the steady state. Okay, we'll keep that halt. C option is the system is absolutely stable. Yeah, that is stable, we know. And the transient terms approaches 0 as t tends to infinity. Okay. There will not be any transients. Even though there will be initial transients, there might be. Transients will go to 0. There will not be transients. They are not saying about steady state. Steady state is still non-zero. As t tends to infinity, transient will go to 0. This is one considerable solution. If not, the next option is. The next option indicates the poles s is equal to minus 2, s equal to minus 4 indicate unstable system. Not at all, right? So this will also be wrong. So out of these two, how we can come to a conclusion? Anybody has any idea? In this system, there is a keyword transient output dominates. So that doesn't look like a nature of a stable system, right? So we are ruling out this. So the correct option will be C. Have any doubt?
No, ma'am.
Okay. Right. Following that, a fifth question would ask a control system is represented in S domain. Consider the following statements regarding the pole of a transfer function derived from characteristic equation. Okay. Fifth question, considering the pole of a transfer function derived from its characteristic equation. Okay. The first option is poles with positive real parts indicates a stable system. Second is complex poles always appear as conjugate pairs. Third option is a pole S is equal to minus sigma where sigma less than 0. S equal to minus sigma where sigma less than 0. You should be careful here. Implies that the transient response exhibits exponential decay. Okay. Uh, Out of this, what is very obvious? Which option is very obvious?
Complex poles always appear in Kajal.
Yeah, convex that we know. It's a statement we know already, right? Complex poles always appear in a conjugate pairs. Either it will be like this, plus or minus. It will always have a pair of poles when it is complex. Even though it doesn't have a real part, it will appear as a conjugate pairs, right? And the first option looks like poles with positive real part, stable. Does it make sense? This region, is it stable? No,
No.
right.
No.
Will be, yeah, correct. So this will be a wrong option, this will be a correct option. And the third one, you have to be little careful because it is S is equal to minus sigma where sigma less than 0. So sigma will also be a negative term, some minus x, let's take. So S will be x, so it will be a positive value. S is equal to 2 kind of, so it will be in the right of the S plane. Transient exhibits exponential decay. Will it be correct for a system having positive real parts? Does it have a transient response that exhibits an exponential decay?
No.
Okay. Actually, the answer is no, because whenever the poles are in right of the S plane, the exponential value, it will be exponentially increasing. Transient response also, because when it has some complex poles, it will increase like this. So there is no point. This will not be correct. But here in the key, there is a mistake there. We have considered this as S equal to minus sigma, where sigma less than 0, right? This is one view we are getting. But actually what it meant is S is equal to minus sigma, and here the whole value, the sigma is negative because it has a negative value, that it meant. So according to this key, it was given that this system, it becomes S is equal to minus sigma only, where it has e power minus sigma t decay. So I think this option, the word formation here, sentence formation here is a little ambiguous. We'll look into this. I'm noticing this time only. Okay, we will avoid this kind of things in exams. Okay, that's it. If you have any doubt, please ask me. Otherwise, we can wind up the session.
Sigma is greater than 0, then C option is correct, right?
Yeah, that is correct. It exhibits exponential decay. Yeah. So I guess that's it. If you have any doubts, we can discuss further. Otherwise, I have this much, and we can wind up the session.
One doubt. Our quizzes will be MCQ based or written based?
It will be MCQs this time. MCQs in the sense you can expect MCQ, MSQ, multiple select questions, and fill in the blanks also. But it will not be kind of short answers. For example, a sentence. It will be short answers like numbers, yes or no, true, false, or 0.1, 0.5 kind of values.
Means
Like,
we have to just select the options. We don't have to write the solution, right?
yeah, you have to. It will be in terms of a number. For example, 50.1 kind of numbers you have to write. Fill in the blanks kind of. There will not be any reasoning answers. Why it is like that? You don't have to write in sentence. You can leave if you don't have any questions.
Thank you, ma'am.
Thank you.
Thank you.